Slide. Like, whoa. Yeah.
Okay, we're a go. Good afternoon. Aloha. Welcome, everyone. So good to see you. Nice to have you here for the continuation of our Princeville Moʻolelo series. Look at all these beautiful faces. Welcome as well to the folks online on Zoom, letting all of us know, of course, we're going to be recording this, so please be mindful of your background noise. And for you folks on Zoom, Patty is managing the space, so feel free to put any questions or comments in there, and she'll bring them into the room. But this is my chance to give a quick little plug before I turn it over to what's going to be just an amazing talk today. So a quick little introduction of who we are. My name is Thomas Dalbert. I'm the Executive Director of Friends of Kauaʻi Wildlife Refuges. We are the nonprofit friends group that supports our island's 3 beautiful national wildlife refuges. And our Princeville Moʻolelo series is in partnership with the Princeville at Hanalei Community Association, which we're grateful to have this space. As a friends group, we were founded over 40 years ago, basically just to help fill in the gaps in funding and staffing and outreach and all the good things to help further the mission of these important spaces. And of course, collectively, we are here to help support our native wetland birds and our seabirds. Very important populations of wildlife that need our awareness and our advocacy and our passion. And today we're going to really move the bar on some awareness around one particular species that's just so important to us here in Hanalei in particular. So as a friends group, what we do, like I said, is we fill in funding and in-kind staffing support and do community outreach like this series itself, bringing our community together, talking story, sharing information, and finding ways for us all to help. So thank you for being here and being a part of our work. We basically, as a friends group, underwrite different refuge programs, do community outreach, support wildlife rehabilitation, which if you've been to the series before, you know it's a big passion of mine. But today, and support keiki education. But today, I'm really excited to share with you that this is the time of year when our board of directors continues a long tradition of supporting education by investments in the future through scholarships in the name of Dan Moriarty. He was the first refuge manager out of Kilauea Point and created an incredible footprint for conservation, building the habitat and inspiring a community. And in particular, he, as I understand it, was an amazing educator in the public. And so it was really great to attach his name to a scholarship fund that helps support young people going out into the future of this work. And I'm really delighted to say that this year, we were able to provide $30,000 in scholarships to 14 young people. Yes. Beautiful faces of all these young people that are going to go out and do amazing things that we can't even comprehend right now. And I just got to say, they're all women. I'm just gonna give a plug for women in conservation. Yeah. Thanks for letting a guy be a part of it, but kudos, ladies. And just really cool, just the areas of study that they are exploring: biology, botany, earth sciences, earth system science, environmental engineering, marine biology, marine science, and sustainability education. You can see the threads and the fingers of this in so many different areas, so many different ways. And again, those bright faces just full of excitement and energy and passion for caring for this place and our wildlife, just like you are today. So I think that's a great segue to turn us to our upcoming series in August. We're so excited to bring back Save Our Shearwaters. Again, the folks who are doing that amazing wildlife rehabilitation with us. Mark your calendar, August 19th. They'll be back to talk a story about fallout season and the seabirds that, again, also really, really need our awareness and our passion and our advocacy during fallout season. So join us in August for that. And today, we have with us in the room 2 amazing ladies. Carly Kano, am I pronouncing that right? She is one of the lead techs on the Koloa Maoli, Koloa Maoli. I do that a lot. I tried to add diacriticals to the name. Or just Koloa translocation project, and is based on Oahu. She graduated from Seattle Pacific University with a major in physiology and a minor in chemistry, and earned a master's degree in ecology and evolution, wow, from San Jose State University. She's passionate about exploring questions at the intersection of psychology, molecular biology, and ecology, and hopes that her love for conservation and public education can contribute to restoring Hawaii's ecosystems and supporting healing through the protection and restoration of native species. Well, now I'm a mess. That's awesome. Very cool. And also with us in brown, and just a quick moment, I do want to give a shout out. We have Eldridge in the background. He is the Deputy Refuge Manager. We again are here to lift up our folks in brown or red today, but that's okay. He gets to be incognito. Bryn Weber in brown. So nice to have Fish and Wildlife on the stage because you are the folks, of course, that we are plugged in to help support directly. She is, thank goodness, our refuge biologist at the Refuge Complex. And she's been working to conserve Kauaʻi's endangered birds since 2016, when she first moved to island to work as a kupu at the Refuge Complex. And since then, Bryn has undertaken what she calls, I love this, a waterbird forest bird sandwich, studying Aleula at Hanalei for her master's in wildlife science at Oregon State, and then spending several years working for the Hawaii Forest Bird Project with the endangered forest birds and the Mosquito Project before coming back to the refuge in the wetlands and the birds that know her and love her. So we're in a treat to have you here talking a story about Koloa, a name that I can almost pronounce. In any event, I'm happy to introduce these amazing ladies. Welcome.
Thank you. All right, so again, my name is Bryn Weber. I'm a refuge biologist at U.S. Fish and Wildlife. This is Carly, and today we are talking about a project that, you know, this just isn't just our project. This is a large project with many different players, agencies, organizations involved. So we're just kind of the faces today. So first, I want to introduce you to our only native duck in Hawaii. This is the Koloa Maoli, and it is a brown mottled duck. It is interesting that the sexes look similar, so males and females are pretty hard to differentiate. There are a few defining characteristics if you can see them really close up. And today this is, you know, the main focus of our talk. So a couple of things we're going to go over today. We're going to start with some Moʻolelo appropriately, and then give a little background on their life history. We'll also talk about some threats this species faces. And then we're going to focus on hybridization today. Then we'll go into our conservation efforts and end with some ways that you can support this species and this project. So in Moʻolelo, so the Hawaiian duck has its place in the folklore and legends of Hawaii. It is said to have been the guide to Imaikalani, the fierce warrior king of Kauaʻi. This warrior was actually blind. So when Imaikalani went into the battle, the ducks would alert him to the presence of his enemies. They would quack to indicate the location. So the warrior king would actually unleash his 10 spears, 5 from each hand, and the Koloa would guide those spears to their target. So just some really cool Moʻolelo to learn about here. And just getting into the life history of this little brown duck. Oopsie. Yep. Sorry, I got 2 screens going on here.
Do the clicker.
Sure.
Yeah.
Sure. Yeah. Okay. Super cool photo. Moving on. So the life history of this little brown duck. So historically, Koloa were found on all of the main Hawaiian islands, except for the islands of Lanai and Kaʻolawe. So you can see the map here of Hawaii. They're now only found in one population that can move back and forth between Kauai and Niʻihau. And I just put in this graph. This is a recent paper that was just published showing this trend of Koloa. So, you know, in the 60s, they, you know, were very hard to find, not well studied, and they've kind of increased over time from 250 individuals in 1985, and then they kind of peaked in 2015. And in the last 10 years, they have been declining. People have various theories. I don't have a single one other than what the rest of this talk today is going to be about. So the current population is really, it is quite small. It's less than 1,000 individuals. It's about 600 birds. So we're talking about, critically endangered species. So Koloa, they will forage in a wide variety of wetland freshwater habitats. That includes, artificial wetlands, also taro farms, and they do move between these feeding and breeding habitats. Like I said, they'll move between Kauaʻi and Niihau, but they're not known to fly between the other islands. So they're considered a dabbling duck, and they're an opportunistic forager. So they'll typically forage in shallow water that's less than 5 inches deep. And they'll eat all different types of insects and invertebrates, including snails, dragonfly, larvae, earthworms, grass seeds, and even, different parts of seeds and leaves of wetland plants. And, they're usually found alone or in pairs, especially when they're nesting or molting. But during the winter months, they actually do gather in some larger numbers. And they are pretty wary birds, so they easily flush, and they're not very easy to study. And on that note, their nesting biology is poorly known, but we do have some data from Honolulu that shows that nesting occurs year round. Most of the nests are hatch between January and May. And these nests are super hard to find. They're like finding a needle in a haystack. So they're usually on the ground. They're always on the ground. They're usually near water, but they can actually be found in the uplands too. And the hens lay 4 to 9 eggs. So just, going into some threats that are endangering this species. Of course, the main one is going to be habitat loss. And historically, hunting pressure likely reduced these populations, but today we'll focus more on the recent declines and threats to this species. So in this photo, you can see freshwater wetlands interspersed with farmland. I believe these photos were taken in the late 1800s. And I don't know if anyone can see this very well, but just pay attention to the background. Do you recognize this location? Does anyone know where this might be? No? It is kind of nondescript. So this is actually Waikiki. It's really hard to see in this photo, but there's a little Diamond Head Peak right there if you squint. So in Waikiki, that actually means the land of sprouting fresh water. So this whole area used to be a wetland system. And so, in the last 100 years, approximately 30% of our coastal plain wetlands have been lost in Hawaii. And then in addition, the shift from wetland agriculture like taro and rice to more terrestrial type of crops has also reduced the amount of wetland habitat. And then of course, we've altered the hydrology for flood control or to serve as municipal water sources. And that just makes these waters and habitats unsuitable for the species. So of course we have to talk about invasive predators when we talk about water birds. So on Oahu, they do have the small Indian mongoose. We are lucky that we don't have them on Kauai. And they're a nest predator. So they're, specifically looking for nests and eggs. Whereas, the pig actually is kind of similar because they don't generally eat adult birds, but they will find nests and actually eat eggs. And then we also have our invasive barn owl on the right there, not to be confused with our native fueo. They are known to take adult Koloa and ducklings. I think I might have even found a barn owl kill Koloa this morning. So it is an ever-present threat to this species. Another thing that didn't make it onto this slide, but is interesting to note, is that bullfrogs can actually take Koloa ducklings, and we have evidence of that when they're very small. And if, I know many of you know about this problem, but I would say the most problematic predator of Koloa is feral cats and the feeding of feral cats by the public. There's been, many studies that have shown that even indoor, outdoor pet cats and feral cats that are well fed will still hunt for food. It is, their natural instinct. So thus feeding of feral cats only bolsters their population. And then some of you may have come to the talk that we did last time on avian botulism. So this is a major threat to the Koloa. It's a naturally occurring soil bacteria that can cause huge die-offs of water birds if left unchecked. And unfortunately, Koloa are disproportionately affected, and they do account for like 60 to 70% of all botulism mortalities at Hanalei. So yeah, botulism is more so a problem at Hanalei than other wetland sites, but Hanalei, I'll probably say many times, is likely the most important site for Koloa. So it's definitely a big issue. And last but not least, the threat to this species is the feral mallard. So domestic mallards were brought to Hawaii in the 1800s, used primarily for sport hunting, but they escaped forming feral populations. And these feral mallards have since become a huge threat for the Koloa, which I'll let Carly explain.
Oh, it's okay, I got it. So as Bryn said, the feral mallards are a huge problem for the Hawaiian duck or the Koloa Maoli populations. And this is largely because they are hybridizing with our native ducks. So the feral mallard is an introduced species, so it's not supposed to be here. And then after getting out from these domestic situations, they have started breeding with the native duck and have created this hybridization problem. So in this next section, we're going to talk about what exactly is hybridization, what is a hybrid, how does that become a problem, and what does that mean for our birds here in Hawaii, specifically the Koloa Maoli. So when we talk about a hybrid is an organism that is produced when you cross two different species. And the important thing to note in this is that hybrids are produced by two different species and not necessarily by crossing two different populations. And so for humans, the species is Homo sapien, and it would be similar if humans started crossing with chimpanzees or something like that. So they're not populations, but different species. And then another thing to note about hybrids is that the DNA that they have within them comes from the two parent species that had crossed. So kind of zooming out into a abstract example to help us understand what hybrids are. So here I have two different books. We have the Very Hungry Caterpillar and the Rainbow Fish. And we can think of these as like two different species. Within these two books, they're going to have different characters, different plots, and they're going to take place in different locations. And we can think of all the stuff that's on the inside of the book as the DNA. So if we were to then take pages from the Very Hungry Caterpillar and pages from the Rainbow Fish and rip them out, and then we kind of, tape a new book together, we might end up with a book in the end, but it's going to be very different from the two original starting books. So in this case, we ended up with the Very Hungry Rainbow Fish. And while this result is hybrid between these two starting books, we can remember that on the inside, the pages and the plot are all going to have come from these two starting books, even though the end story might be very different. We also see hybridization happening in animals. An example of a common hybrid cross within domestic animals would be a cross between donkeys and horses. So if you were to take a male donkey and a female horse and you cross them, you are going to end up with a mule. So we started with two different species that are somewhat closely related, and then the resulting is going to be our hybrid. And then just remembering one more time that the DNA within this hybrid is going to be coming from both of those parent species. It might be in different degrees, But this aspect is something that we want to keep in mind as we move forward, because we can leverage this to kind of help when hybridization starts to become a problem. So I'll just tuck that in the back pocket and we'll bring it out in a little bit. So within Hawaii, we see hybridization happening within our ducks. So we've kind of talked on the Hawaiian duck and the introduced feral mallards, and these two species are crossing and creating these hybrid between the Koloa Maoli and the Hawaiian duck. And this can be a problem for a number of reasons, but we're going to start with kind of like a visual example to help us understand how you can lose species through hybridization and why it might be a problem for native species when you have introduced species. So we're going to start out with our Hawaiian duck as well as our feral mallard, and both of them have full ancestry from both of those two different species. We're going to cross them, and then the resulting organism is going to be our hybrid. So when we look at on the inside the DNA, we're going to see that some of it is going to have come from the Hawaiian duck species, and then some is going to have come from the mallard species. So this organism has a little bit of both. So if we were to then take our hybrid and, you know, it's out in the wild and feral mallards are very abundant and the Hawaiian duck is not so much abundant, it's probably more likely to be encountering other hybrids or feral mallards. And so more often than not, you're going to get crosses between hybrids and feral mallards or hybrids and other hybrids. And if we do this cross, we see that the resulting offspring is going to be still having DNA from both the Hawaiian duck and the mallard, but the percentage from the Hawaiian duck has become lower. And this is a problem because, you know, we've only gone through 2 generations, and over time, this could become even less and even less to a point where we might eventually risk losing the species altogether. So that example is what happens here in Hawaii, but we see that feral mallards are a threat to a lot of different duck populations. We see that in the African black duck, the yellow-billed duck, the Mellors, Australian black duck, and all these other ducks are all at risk of hybridization with feral mallards. So while here in Hawaii, we are risking losing the Hawaiian duck, we see that feral mallards pose a threat to a number of different ducks all throughout the globe. And then kind of bringing it back, one thing to note is that even though over time we might lose this, the DNA from the Hawaiian duck, it's important to note that even in hybrids, you do have DNA from that species. And so this is really important because, you know, if you let it go too long, you might risk losing it. But if you catch it at the right time or early enough, you can leverage this, you know, small portion of that remaining genetics to potentially reverse the effects of hybridization and bring a species back. So the reality of our situation is that the population of Koloa Maoli is declining. They were increasing for a little bit, but within the last 10 years, we see this pretty rapid decline within their population. They're currently limited to Kauaʻi and Niʻihau, which for a species being limited to a single location isn't always the best thing, because if some random or stochastic event were to wipe out that one population, then we risk losing that species because it's not buffered in other locations. And then currently we have a lot of these hybrid swarms that are persisting across other islands. So on Oahu, we have a lot of those Koloa Maoli mallard hybrid swarms. We have them on a lot of the other main Hawaiian islands as well. And while this is currently very bad and is putting the Koloa at risk of extinction, it's promising that, as we remember, the hybrids do have ancestry from the Koloa Maoli, so we're at a place where we're going to leverage that to hopefully reverse the damage that hybridization has done. And taking all of these things into consideration, we know that immediate action is needed. And so if we were to just sit around and not do anything, then the Koloa is very likely going to go extinct because of this hybridization with the feral mallards. So based on the fact that we need action, we're now going to talk about some of those conservation efforts and what our team is doing to hopefully recover this species.
Great. So in 2004, the Koloa Recovery Implementation Group was formed. This is essentially a working group comprised of state and federal biologists, including, U.S. Fish and Wildlife Service, USGS, and other researchers from various universities and agencies. So this group meets periodically to share knowledge, research, and conservation projects with that main goal of working towards the recovery of Koloa Maoli. And then, of course, with the rise of hybridization, this group has extended to include some of the top water bird geneticists in the country at various universities. So from here, I just want to back up a little bit. I don't know if any of you are familiar with recovery plans, but this is something that's developed by U.S. Fish and Wildlife Service for each endangered species. And they lay out a plan or a framework for recovery actions with the ultimate goal of downlisting or delisting the species. So as water bird biologists in Hawaii, this document is kind of like our holy Bible. The most recent version is from 2011, and it covers all 4 of those endangered species listed or pictured there. And for Koloa, this plan centers around a few core ideas. So the first one is that, we need management of our core wetlands. And this is to ensure that there's suitable habitat, including maintenance of appropriate hydrological conditions, control of invasive species, plants and predators. And this is basically just ensuring that we have the boots on the ground at the site to monitor the water bird populations. The next part of the plan is focused on, the population being stable and increasing. So of course, you want a certain amount of birds before you can downlist the species. For Koloa, they have that number around 2,000. So to basically downlist the species, they would want over 2,000 individuals for 5 consecutive years. And they would also like to have a population viability analysis conducted, which I'll talk about in a second. And then to delist, that number is over 2,000 individuals for 10 years, and making sure that those wetlands are managed at 85%.
Everything went okay.
And the third kind of main idea in this plan is that we need to establish self-sustaining breeding populations distributed throughout the Koloa's historic range. And that's just to ensure against population declines from localized demographic stresses. So for example, like we were saying right now, we really only have one self-sustaining population of Koloa on Kauaʻi, and the other islands have populations of hybrid Koloa that are continuing to breed with mallards. So these aren't really considered true Koloa populations. And then, last but not least is this feral mallard hybridization issue. So they're focusing on the threat of that being removed from all of the islands. So, the main takeaway here is that Koloa are considered a 1C or critically endangered species and a high priority. So a lot of management and thought goes into the management of this species. And, conversations about translocating these birds has been discussed for many years. I think they began in 2021, actually. And, we're finally here today and ready to take action. So this is kind of an exciting time for Koloa. So, how do we reestablish multiple self-sustaining populations? I'm sure many of you guys have heard of wildlife reintroductions before. Sometimes people use the word translocation, but I really like to use that term reintroduction because we're moving a species back to an island where it was found historically. And the first thing that has to happen is a feasibility study. Traditionally, wildlife managers and population ecologists use this old school program called Vortex. It's basically a modeling program and allows you to put in various inputs and then determine what that population is going to look like over 100 years. For this project, we also used, some pretty high-level genetic modeling to even see if this type of reintroduction would be possible. From there, if it passes that stage, you next determine, your donor site and recipient site criteria. We're not just going to move birds from here to there without really putting a lot of time in. So, for example, for our recipient site,
I ended up not cooking, so I thought we'd just go
that
like
was
maybe pick up.
extensively managed and has protection from
would just
various
pick up like
threats
a
such as
frozen
invasive
pizza.
predators and sea level rise.
That's not what you did.
Of course,
I
these are
noticed something,
freshwater
though.
birds, so they can't have
Are those peppers?
Can we sit on the side?
which is a
Side.
threat for a lot of our wetlands across the state.
Oh, to bake?
We're also looking for a
Cook
site
everything
that has
inside the
high has
Well, then
individual
we're
high
now.
percentage of
That's
Koloa
what I'm
genes
take out.
and
Did you look
low
in it?
percentage of
Yeah, it looks
allergens.
delish.
Did
And
you
then, of
look in it?
course, for the
No.
donor site, we're looking for one that has a large population of healthy individuals and
Oh,
close to 100% Koloa genes.
Beep.
And then from there, you can kind of begin to
This
develop a plan
one
or a
is the fish.
pilot project. And in our case,
Like,
we
they've been on
chose to
the
start
top of the stove. I didn't
conservatively
realize it was still that
and
hot. I
plan
just
for a
kept it hot.
pilot project.
Okay.
So the
That was
reintroduction
sensible.
site that was chosen
Trippy. It's trippy.
was
Breast meat's
among the
trippy.
working
It should be
group.
cut up
It
into
was
little
decided that
pieces.
James Campbell
Interesting
National
things going,
Wildlife
but it
Refuge
tastes
would
really
be the
good.
best
Once you get
candidate
past the texture and
for
stuff.
a
It
reintroduction
came out
site.
nice. This came
I'm not
out.
sure if any of you have been there, but it's on the north shore of Oahu and has
I think it's
150 acres of protected wetlands. This is a highly managed site, a lot of great staff, monitoring wetlands and birds. And there's a lot of protection from predators there. They have an ungulate fence surrounding the wetland areas. And then within that, they have a very intensive and highly successful predator trapping program. To the point where they basically never see mongoose or cats, within those wetland areas. One thing I learned recently is that James Campbell is protected somewhat from sea level rise, as it has this massive sand dune ecosystem that would be blocking the water, the sea level rise from getting in. And then this site does have the highest Koloa gene percentage of any of the sites that were considered. So there's the individuals that are still 75% Koloa and 25% mallard. And then prior to the introduction of feral mallards, this wetland would have had pure Koloa. And so additional funding was actually secured recently for a mammalian exclusion fence, quite similar to the one that we installed at Kilauea Point recently. And that would encompass even the current ungulate fence, keeping all species of predators out, down to even small mice and rats. And they're actually breaking ground on that this year, so that's really exciting. And then our donor site, and why I'm standing here today, is of course Hanalei National Wildlife Refuge. This was kind of the no-brainer donor site for several reasons. It's considered one of the most core wetlands and is the most important site for Koloa in the state, as it holds the largest population. And then past and recent genetic research has shown that the individuals at this refuge possess 99% or greater Koloa genes. And so much of the research done on Koloa in the last 10 years came from Dr. Chris Malachowski. He was with Oregon State and spent many years in the field over here from 2012 to 2016. And one interesting thing he found in his research is that there's actually a skewed sex ratio. So there's one female Koloa to every 3 males at Hanalei. So, females are thus the limiting factor in this equation. And there's actually this idea of spare males who may may not ever get a chance to mate. So for this reason, we believe that moving a small number of these hatchier males to James Campbell should not be a detriment to the Hanalei population. Right.
Okay, so now we've done all the planning and the discussion. We've picked our 2 sites, and at this point, we are in a position where we're ready to actually, start doing the boots on the ground work and start making moves for this translocation. So to start that out, we need to first assess the populations at both the donor and the release site. So kind of like what Bryn was saying, we have to assess the genetics of that population and just ensure that those are in fact good sites to be using and considering. So what this looks like is doing an banding and trapping effort at both of those sites. And what that looks like on a day-to-day is going out in the evening and setting our swim-in traps. And then the next morning around sunrise, we go out and we check and we see if we have caught any ducks. And that can range anywhere from having no ducks that morning, or sometimes when we really score big, we get anywhere from 8 to one time I think we got 12. So it all just depends, but that is kind of what banding or trapping ducks would look like. If we catch ducks in our trap, we have to get information and process them. And so we remove them from the trap that's in the middle of the pond, and we give them a nice little ride in what we call our duck truck. And they all kind of just sit in there while we bring them to the bank. And then after we have them in a place where we can start collecting information from them, what this looks like a lot of the time is we start out, we give them metal bands and also a field readable band, which I have right here. So you guys can pass this around and look at what those might look like. And those help us to individually identify what the birds or who those birds are. For me, it's a little bit hard to just tell from physical features all the time because they might look similar. So, it's a helpful way. So if you recatch that bird, then you'll know, okay, this bird is 00, or this one is number 72. And it just helps us to keep track of those individuals. After that, we will take morphometrics. So we'll get a body mass, we'll get lengths of different things like their wings and their legs and their bills. And all of this is helping us to understand physically what those normal ranges for the different species might be. We also will take photos so that we can also, physically be able to identify them. Hopefully in the future, we'll be able to make a key so we can look at external physical features and then hopefully be able to identify whether we have a hybrid or a full Koloa. And then most importantly, we also will take a blood sample. And this is important because it helps us to understand the ancestry of that particular duck. So if you guys have ever seen a mallard, the Koloa is pretty similar to the female mallard. And so when you have them in the hand, it can be difficult to distinguish. So that's kind of where the genetics aspect comes into helping us understand the ancestry of that duck. And then when we're just doing our banding and population assessment, then after we're done processing them, we'll release them and they'll fly majestically out to the pond. Sometimes not so majestic, but. So after we've done our assessment of those two populations, we're now at a place where that phase of the project is done. And Bryn kind of mentioned it before, but the ducks that we had sampled here up in Hanalei at the Hanalei National Wildlife Refuge came back with 100% Koloa ancestry. And then the ducks that we had sampled over at James Campbell came back with about a 75% Koloa ancestry. And that is within like single individuals, they're gonna have about 75% of that Koloa genetics. So we're now at a place where we're ready to start trapping and getting our cohort that we're gonna translocate to the reintroduction site. So what this looks like is going out and doing the same trapping effort as before. All of the ducks are processed similarly to before, getting the bands, getting the measurements and the photos and the blood sample. So all of those things are the same. The only thing that's different in this phase is that all the individuals that we capture are then going to be assessed as potential translocation candidates. And the things that we're looking for a cohort are apparently healthy. So, you know, we want to make sure that any birds that we're translocating are going to be healthy individuals, that the translocation process is going to be that they're going to be able to handle that well. And so that is kind of our number one criteria, is making sure that that bird is healthy. We are looking for males. So here we know that the ducks at the Honolulu National Wildlife Refuge are kind of that 3-to-1 male to female ratio. And so by taking males that perhaps aren't breeding here, we're gonna translocate them to a site where they could potentially form those pair bonds with the resident ducks over at James Campbell. So getting them from a position where they might not be breeding or ever breed to a place where they have all the ladies available to them. And then lastly, our criteria for our translocated ducks is hatch-year ducks. And this is just because when we translocate the birds, having a hatch-year individual will increase the likelihood that it's going to stay at the reintroduction site. So once we've captured our cohort, what that looks like is the birds will then be housed in an aviary that is at the Honolulu National Wildlife Refuge. And they're going to be housed in here and monitored very closely by a very skilled aviculturalist who's going to make sure that they're adjusting well to captivity, that they're, you know, eating well, and that they seem to be doing well. And at this point, if any of the ducks that we have seem to be having a hard time adjusting to captivity, they're released back out. So no one that seems to be overly stressed is going to be kept in the cohort. And while they're being housed in these aviaries, we're going to be doing genetic and health screening. And so for health screening, we want to make sure that they're not sick or having any viruses. And so the two that we are looking for are reticuloendotheliosis, or REV, and then avian influenza. And so they kind of are getting this clean bill of health prior to the translocation and being brought to the release site. And then also while they're in house in these aviaries, we're going to be doing the genetic screening. And this is just to confirm that all of the ducks that we're bringing to the release site are a high percentage of the Koloa Maoli ancestry. Then once all of these things come back great, they are healthy and they have that high Koloa ancestry, they get to be transported over to the new site. And so they'll be transported by a helicopter or a commercial airplane. Helicopter is more ideal because it's a quicker transport, so we can you know, bring them directly to the refuge. And then once they get to James Campbell, they're going to undergo what's called a soft release. And a soft release is kind of this gradual process of releasing any animals that you're bringing to a new site. And this just helps them to have this acclimatization period to the new site, and it's going to increase their chance of staying there. And so what that looks like is once they get to the James Campbell National Wildlife Refuge, they're going to stay in an aviary over there just for a short period of time while we let them adjust to the new site prior to releasing them. And then once they have undergone that adjustment period, we get to release them, and we'll continue to monitor them. And so prior to releasing them, we are going to equip all of the birds with GPS trackers. And this helps us to monitor their movement, where they're at, make sure that they're staying on the refuge. And then also it can help you monitor survival as well. So if you have the GPS stops moving, so those are all the things that the GPS trackers will help us do. And then following the release, we're also going to continue with nest monitoring and then offspring sampling. And so the whole goal of our project is that in subsequent generations, the population's genetics are going to move more and more towards Koloa ancestry. And so how do we, make sure that that's what's happening is we continue to monitor the population at James Campbell and just ensure that that is what's happening. And then once they're at James Campbell, we are going to continue to protect all of the birds that we've moved. And this is going to be done through the ongoing predator control efforts, the intense trapping that we do for mongoose, cats, pigs, and dogs. And then in addition, in this summer, actually, which is now, we're breaking ground on the mammalian exclusion fence. And so that's going to further protect all of the birds that we're bringing to the refuge. So they're going to be double fenced in. So they'll be extra secure and protected. And then lastly, one thing that's really important for protecting any of the translocated birds is just continuing to remove any feral mallards that might be at the site. Because as we've talked about before, if you bring, the Koloa over to a site where there are feral mallards, then you're just going to end up back in the same situation as we are currently. So this is a huge important aspect of protecting all the birds that we're bringing. So another thing we need to do is, how do we make sure that the translocation was successful? What does that look like, and how are we measuring that? We need to be able to define that. So what that looks like for this project is that the survival of the Koloa exceed 60% or Kauaʻi's survival rates. We want to make sure that they're doing well at their new site, and so we want to make sure that it's either similar or exceeding that of Kauaʻi. We want to make sure that the birds that we're bringing over are in fact breeding, because that is what's necessary to move the population's ancestry more towards the native species. And then we want to make sure that the productivity and the output of these birds is going to exceed or meet that of Kauaʻi. And then lastly, running another one of those population viability analysis, making sure that their probability of extinction is going to be less than 5%. So in summary, the Koloa are at a high risk of extinction, and so we really need to be doing something, and immediate action is definitely required. The current translocation project that we're doing is slated for 2 years currently, and it's a pilot project and making sure that the concept is working. And then if additional funding is secured, it could potentially be extended to 5 years. It would be really great. And then if we see that everything's working, this project could then inform further translocations, potentially expanding to other sites, whether it be more on Oahu or eventually different islands. So that is what we have been doing, but there are also things that, you know, all of you guys can do as well to help support this kind of work and to help recover the native Hawaiian duck. So some of those things can be just telling your friends and family about the Koloa. A lot of people actually don't know, maybe, you know, on Kauaʻi it's different because you guys have them, but on Oahu, a lot of people that I'm like, oh, I work with the native Hawaiian duck. They don't even know that we have a native Hawaiian duck. So step one is just telling people about it and just educating people that it's a thing. The next thing that you could do is don't encourage, you know, feral mallards, don't release wild ducks into the population. That's kind of how we got into the position that we are now, is these domestic ducks getting out and becoming these feral populations. And then making sure you're not feeding wild ducks, because sometimes, you know, we often hear, oh, you know, that's a good activity to do with your kids. Go take them to the lake and give the ducks bread. But bread actually isn't that good for ducks. And so even if you think you're helping the population, you might actually be hurting them nutritionally. And then by feeding ducks, you also might be encouraging mallard survival, which is definitely not what we want. And then lastly, you can volunteer at the Honolulu National Wildlife Refuge. Look how beautiful this is. Don't you want to be here? This rainbow went all the way. You could see the whole thing. So you too could be seeing this in the morning, every morning, maybe, if you're really good. So these are all things that you guys as, you know, the community can do to support this kind of work and to support the recovery of the Koloa Maoli. And with that, we are done with our presentation, and we just want to thank you all for coming and listening to us for a whole hour talk to you. And then we also want to give a special thanks to all of the people that have been very instrumental in this project. You know, as Bryn mentioned, we're just two of the players in this whole big project that has been in the works for a very, very long time. And so, you know, all of these people are very instrumental to making all this happen. So with that, we welcome any questions that you might have.
Who is first?
Well, I have several questions. If you, do I need to use mine?
We can repeat,
No.
but you're close.
Okay, so how can you absolutely for sure know you have a male?
Oh,
Well,
for it.
males and females have different parts. So that is one thing. Yeah, I don't know if anyone had that conversation with you, but that's one way that you can do it. And then, yeah. So they do have different parts, and then yeah. And then sometimes when you have them in hand, there are certain features that you can look at, like fill color and things like that.
Underneath their little chin.
Yeah.
And on their speculum, but it can be really tricky, of course, with the young males versus females. It's kind of a classic issue.
Mostly you're checking inside the cloaca to see if there's evidence of.
Yes.
Okay, very good.
That can be the for
Thank you.
sure
Great question.
way.
Now, and then about fence over James Campbell, how do you protect against barnels and goats?
So we are protecting against barn owls. We do barn owl hunting. So that's one way. And for toads, we actually just installed this like saltwater pump where we're gonna add a little bit of salt water to the ponds, not enough to where it's, you know, out of the range of the birds, but the toads would be sensitive to that slight increase, and that is going to hopefully help us curb the frogs as well as some of the invasive bulrush. Yeah.
Okay, that's good. And then I have one more quick question. The 60% for survival, is that after years, 1 year, or when are you measuring this?
I think just over.
It's like annual survival.
Yeah.
Yeah, so with the GPS transmitters, you know, tracking, did that bird, did the cohort, you know,
Are they still
60%
moving
of them
around?
survive.
Are you also trying to measure food success? That I would work up and see.
Yeah, so we do a lot of repro surveys as well for the birds over at James Campbell.
It's actually a lot easier.
So it's every day we
at James Campbell. Their environment is easier than Honolulu.
Yes.
Yeah. Yeah, yeah, exactly.
Very good.
Thank you.
I don't know a lot about sex education. I guess the question at the moment really is advantageous for the donor population. Play space. And you move the males to the best. But what is it that has led to that imbalance between male and female ducks here? And is it an environmental factor that is modifiable? Do you know why that is? And does that make population vulnerable in an ongoing way because of that?
Yeah, I mean, my answer is kind of simple. It's basically we don't really know. Yeah, we're not quite sure. You know, females in general, across all species, they're more vulnerable to predation. So when they're on that nest in this species, it's only the female that's sitting there on those eggs. The male doesn't contribute at all. And that's really stressful on the bird. So, you know, they do get off to feed a little bit. And, you know, if, you know, that bird is already stressed, it could more easily be, you know, predated upon by a predator. And so a lot of that, usually a sex ratio that's skewed with more males has something to do with the stress of breeding. I don't know if Marin raised her hand. if you might have more insight.
Both of the work, Kauaʻi and Hawai, the same thing that Brandon started. So across ducks, a lot of ducks. It's not just the Koloa. So depending on the species, even at James Campbell, we have a 2-to-1 male to female ratio, and that's actually considered pretty good. But essentially what ends up happening is that, so you have what Bryn describes where in Koloa in particular, when the females are sitting on the nest, they tend to get gotten by cats is what he found. Because he had what are called like VHF transmitters put on the females' backs so that he could find nests, and then he would check them every day. And what he found was they were gotten by cats for the most part when they were sitting on the nest. What's interesting though about Koloa is that male-female ratio in botulism is pretty much 50-50. So even across species. So most likely it's because of that depredation. There's also what you can see in other duck species is even after that female gets off the nest and has babies with her, when you have that high sex ratio, the males will continue to harass her and sometimes stress her out. And so she just gets too tired. And that drives it's actually driving issues in duck populations across the mainland USA, but Koloa in particular have that.
Yeah.
Mm-hmm. Yeah.
Correct?
Yes.
Okay.
Yeah. Mm-hmm.
Of our 3-to-1. Yeah.
Mm-hmm.
Just to confirm it.
Yeah. Yeah. Regina?
That coincides.
Yeah. Mm-hmm.
Questions. The first one is the ratio of male to female on Oahu at that refuge, is it the same 3-to-1? Do you know what it is? 2-to-1?
Yeah.
So you have more males, and on the top of it, you will bring males from here. How will you ensure that those 100% males, 100% Koloa ducks will outcompete the ducks that already live there, hybrids.
So at James Campbell, we were doing a lot of the genetic testing of the population. So one way that we hopefully encourage the translocated males to form pair bonds with any of more feral mallard ducks out of the population.
I see. And the second question is, ducks can fly. How will you ensure that they will not come back?
So a lot of the research that we've done, we haven't seen a lot of evidence of movement islands. And so, you know, we can fly, but haven't really seen inter-island movements. And then that's also a reason why we want to translocate hatchier males that hopefully they are more likely to stay at.
I see. Thank you.
Good questions.
Have some online as well, maybe?
Okay, Patty?
Okay, I have two questions, but I'm gonna add two together as well. Do we have an estimate of the number of mallards in Hawaii? And, oops. Sorry. You can answer that. And do you have an idea of the ratio of the number of mallards to native ducks in Hawaii?
Super good question. I don't know that off the top of my head. Yeah, there's waterbird surveys conducted biannually that the state runs across all of the islands, and so I'm sure they're counting ducks in those surveys, and I just don't have that data. But the state would have the data on, you know, mallards and hybrids that they're seeing on other islands. Yeah, it's a good question.
It's also hard to answer without the genetic aspect as well, because, you know, sometimes they can look very, I think I just broke this, sorry, very similar, like the female mallards do look very similar to the Hawaiian duck or even the hybrids, and so that's where a lot of the genetic work does have to come in into confirming the ancestry of those ducks.
And then one additional question, do we know if Koloa and hybrids have different breeding success rates?
That's another great question. It is. Yeah, like, you know, a lot of our research and funding in Hawaii is very limited, you know, the number of grants and monies that we have coming in. So all of that money gets basically funneled to our endangered species. And if we had all the money in the world, I'm sure there's all sorts of awesome undergrad projects that could study that. But I think, you know, everyone's just so focused on conserving our native and endangered ducks that that's kind of where the focus lies. That would be my answer, but I'm not sure. Maybe someone at a university or something is looking at that.
I feel like mallards are a little bit more.
Yeah. Yeah.
So if I were to just go off of behavior, I would say that mallards are probably more aggressive breeders, and so they probably have a higher success.
I've got two questions. How often how often does the Hawaiian duck breed a year? And what's the definition of a hatch year male?
Yeah, I was realizing we didn't fully describe that. So it's basically a male that is hatched within the last year. So it could be, you know, we're looking for anything that is just barely fledged, so able to fly up until, you know, about 12 months. And then what was the first?
How
question?
often do they
How
breed?
often do they breed?
Like
So
in a year?
yeah, so again, there's limited information. In general, it seems to be once a year, maybe twice. We don't really understand. There haven't been that many ducks that have had transmitters where we've been able to follow them and say, you know, definitely breeding 2 times a year. But
One more question. What's
Yeah.
the average life of a Hawaiian duck? Any idea? I mean, a healthy.
oh man,
We did have that one.
Yeah.
That was like
That's
not
cool.
one back in February. 14 years old.
Yeah, banded by Chris. Yeah, yeah, it was cool to catch that duck. It was, wow. Yeah. Go ahead.
Okay, you talked about the traps.
Yeah.
Why would a duck enter a trap? How are you attracting
Yeah.
them?
Yeah, so we actually bait it with corn. We go out, we do surveys, we look for ducks foraging, and then we're trying to find nice spots where they're going to feel safe, kind of among a lot of vegetation. And then we start putting corn down, and you want the water a certain level, and so you're just hoping that these ducks are going to start feeding on this corn. It's pretty labor intensive, and at Hanalei we have the issue of dealing with nene and gallinule. So we're trying really hard not to catch nene and gallinule. You know, gallinule are another dangerous species, and pigs. We were worried about that, but we actually didn't have any pigs in the corn. I don't see any wood to knock on. But yeah, so it's an intensive pre-baiting effort to get them coming to that site like 2-3 weeks beforehand. And then you put the trap out there, and it's basically like a corral trap. So you leave it open at first, and there's no top on the trap, so they can start feeding in the trap. They get used to it. And then on the day that you set the trap, you actually take the ends that are like this, and you turn them into a little funnel that's just wide enough for a duck to get in. And then you cover the top with a little net. And so they're like, oh yeah, this is my favorite place to get dinner. And then one night they go in there and they kind of just get stuck when they hit that lip. I mean, the smart ones can come out.
Get out.
Yeah.
Can even get stuck when it's open. You're like, and it's right there. But a lot of it is just like, making them feel like, oh, this is a great place, get dinner. Oh, what's this weird metal thing? Well, I guess I can still eat and go in and out.
Yeah.
And then you finally close it. And, but then they're out, within less than 12 hours.
Yeah. Yeah.
Dr. Jeff?
Does James Campbell also have alku'u and cattle egret?
Yes.
Okay, so, and how do you control for them?
Well,
That's
Sorry,
it's a
black
controversial
night
topic.
heron.
Yeah,
Sorry? What?
it's a controversial topic. I know there's some folks on Big Island who have been considering doing a ku'u removal, but that idea hasn't been met with much, momentum at all. So I don't know of anyone doing a ku'u removal in the state as a
I've
native
seen them
species,
follow.
so-
I've seen them follow a mom with ducklings and follow
Oh,
at the
God.
back,
Yeah.
like
just
pluck off the
picking up-
back duckling, and of course we also see them eat other baby
Yeah.
water birds.
Oh yeah. Yeah.
So
Nothing's being done for a ku'u. We don't want to go there.
yeah,
But
but
yeah.
cattle egrets probably doesn't have a support group.
Yeah.
Okay.
Yeah. They don't have a support group.
Oh, good.
No. No.
Thank heavens. Thank you.
Yeah. Yeah. And back there. Yeah.
Are there other locations on Kauai where you find the Koloa? And if so, are you moving them to a more protected area at all?
So yeah, you can find Koloa all throughout the island, any freshwater streams, golf courses, anywhere where there's kind of that emergent vegetation that they can feed in. I've seen them in, Waimea stream or river. I've seen them in the Ulaka'i. The Hanalei is really where they're congregated the most in terms of like a breeding population. And then what was the other part of your?
Rather transport them to a more protected environment?
So the permitting for this species is really intense. It's a huge process to go through to make sure all of your endangered species permits are in order. And so on the permitting and, minimizing disturbance side of things, we're really only focusing on handling birds that are part of this project. We do just want to minimize disturbance, and there's state land, state refuge or state wetlands that have predator control occurring, and various other conservation efforts to protect some habitats around the island. But as Fish and Wildlife Service, we just work within our boundary. Yeah.
I can see why that would be important for the average person out there to tell other people why
Yeah,
it's important to protect
definitely.
the ones that are out there on their own.
Exactly. You could have them in your backyard, easily. So yeah, that would be great.
So when you talk about hybridization, what do you mean when you say that you can leverage the remaining Koloa genes that are left in the hybrids?
So, within a hybrid individual, there is genetics from both the two parent species, right? So, in a Koloa mallard hybrid, there's going to be some of that Koloa ancestry within that individual. And so, when we translocate ducks that have that high or close to 100% Koloa ancestry into populations where there's these hybrid individuals, when those breed, we can hopefully shift the population back more towards the Koloa ancestry. So in that kind of visual example where we crossed the hybrid with the full mallard, we saw that in the next generation, the Koloa genes were a lot like diminished within the offspring. And so the thought by leveraging that is that when you translocate or bring these ducks that have 100% Koloa ancestry, that it's going to be kind of moving towards the opposite direction and like more Koloa ancestry and less of that mallard ancestry. Does that make sense?
Yeah, I thought there was a more complicated like genetic
No.
answer about
Yeah.
Anyone else? Wow, what wonderful questions. What a great dialogue. You didn't break it, all good. Thank you again. This was fantastic. And again, thank you to all of you. It's all of us together that are making this happen. So thank you for your interest, your great questions, and your continued support. Have a great afternoon. Thank you.